Good morning to you all, and welcome to the Water for I Technology Edition. It is a real pleasure to have you all with us. The theme of this 2-hour session is the future of the water borehole industry in Kenya, with a specific focus on technology. Ladies and gentlemen, we have the pleasure to be joined today by the Ministry of Water, Sanitation and Irrigation. We have with us representation from the county governments. Also, the Water Resources Authority is with us today. I'm very pleased that the Kenya Water Industry Association and its members are represented, as well as the Geological Society of Kenya. We will have on our panel 2 key industry players, that is PRD rigs and Epiroc. To get us started, we will play the national anthem as our prayer for today. Ladies and gentlemen, mabibi na mabwana, my name is Dr. Gadhuru. I am the Managing Director of Kipya, Africa. We will start with a short presentation on the water borehole industry in Kenya, with a focus on technology. Let us step back to 43,000 years ago. Right here in Africa, we were digging shallow hand-dug wells. And you can see in the image there on the presentation, some of the tools that were used. They needed a sharp edge. They needed a handle for leverage to be able to penetrate the earth and dig down. This was a very basic form of digging shallow hand-dug wells. Essentially, digging into the ground is a mining exercise. And this is why we need to understand the geology. But also, digging into the ground is a mechanical exercise. This is why we need equipment. Our hands alone are not sufficient. We need to deploy suitable equipment in order to penetrate the ground. So our forefathers, with their mechanized digging, also had to remove whatever they crushed or cut at the bottom of the hole. And this is what we call bailing out, excavation, removing of the cuttings. This mechanized digging plus the bailing is what we call drilling. It is a form of boring, a form of creating a borehole. So a borehole, in essence, is a mechanized hole through drilling that's dug. But let us go a step further. In China, 2,000 years ago, they created another form of drilling where men would jump on a beam. And again, this beam gave them the leverage that they needed to apply a downward force. This downward force is what we call the feed, or the feed force in the modern engineering language. But also you will note that along this beam going down is a rope. So they discovered that using a twisted sisal rope, they could generate not just the force required to hold the tool at the bottom, but also the rotation force that is needed so that each blow at the bottom of the hole is knocking on a fresh surface, and therefore you're able to penetrate the ground more efficiently. Ladies and gentlemen, it has been recorded that the Chinese took 10 years to drill a 200-meter water well. Imagine that, 10 years to drill 200 meters. So certainly there's been improvements in technology. Let us look at what happened then 200 years ago in the UK. The picture you see there is from a company called Dando. And Dando is a company in the UK that started drilling what they called tube wells in England to supply clean water after a cholera outbreak. Dando is very much in business today. Interestingly, 150 years ago, Dando were in Ethiopia as a drilling contractor in what was called Abyssinia, drilling tube wells, what are now known as boreholes, water boreholes. Also at that time, a company in England called Ruston and a company in the US called Bucyrus partnered together, what is called the Ruston Bucyrus Limited, to start manufacturing simple cable tool rigs. They took their principle from the beam that we saw earlier in the Chinese image previous. They then applied a mast, and using this beam and mast concept, and with the advent of steam engines and then petrol-driven engines, they put together what is known as a cable tool drilling rig, because as you can also see in the image there, there is a cable that's going right above the crown at the top and down the mast. The cable, initially from sisal and then from steel, and then variations of cable that have a core made from sisal rope and a steel outside. At this time, 200 years ago, a 200-meter well took 6 months to drill. So already there was significant improvements in drilling penetration rate efficiency. In the US, there was the Ruston Basiras company. There was also other companies like Schmidt and Company who manufactured their own rigs at home. So the rig you see in the image there in the US 100 years ago is manufactured by a Mr. Schmidt using the chassis from his vehicle. And you can see that the traditional form of the mast is very much in use even today. Note the profile of the mast. Then, 70 years ago, Ruston Basiras company decided to put the cable tool drilling rig on a classic Bedford truck. A number of you will recall the good old Bedford trucks. I think there may be 1 or 2 still operating in Kenya. These are reliable machines. But the beauty is that it was far better to use these trucks because of things like ground clearance. It gave the opportunity for these drillers to go into areas that were not easily accessible as the truck could get in. The other thing was that as the rigs started becoming bigger, it required a bigger truck or a bigger vehicle because of the tonnage, the weight, and the spread of that weight, and regulations in relation to axle loads on roads. This cable tool rig was then quickly followed on by hydraulic rigs. The advent of hydraulic rigs brought on rotary heads. And these rotary heads would drive rods, and at the end of that drilling rod, there would be tricon bits. These tricon bits used drilling mud, a process adapted from the oil and gas industry. Companies that were in this hydraulic rig manufacturing business are well known. Dando in the UK, Krelius, which was later acquired by Atlas Copco in Sweden, Gefco and Schramm in the USA. So now let's come back to Kenya and let's observe what was happening in Kenya. In Kenya, the cable tool drilling rig had been brought in by companies like Krelius Terratest, eventually acquired by companies like Kenya Drilling Limited, also used by drillers like JB Drilling, I beg your pardon, and welcome to Tom Armstrong, who's with us today. These companies took on the cable tool drilling rigs, but also started to upgrade because of productivity requirements. One of the very big drilling rigs, hydraulic drilling rigs that initially came to Kenya was by a company called Molem Construction from the UK. But indigenously, we note the period 1998, 1999, where there was an inflection point of the acquisition of hydraulically driven rigs. One of them is shown in the picture on this slide from Spar Drilling. And they're still with us today, and welcome very much, Spar Drilling, to this meeting. That rig of theirs, the first rig, was sold by a gentleman called Parathamana. And Parathaman, or Parathamana, is the gentleman then who led to the Parathaman Rock Drilling Company, PRD as we know it today. Pneumatic drilling became the way, and the reason it became pneumatic drilling was because of efficiency. There was developed the DTH tool, the down the hole hammer. The down the hole hammer provides for fast drilling. So today you will find an open hole, 200 meters, 8-inch diameter in consolidated formation can be drilled in 1 day. This is a significant improvement in drilling efficiency. Down the hole hammers, air drilling are very efficient for deep, underbalanced drilling of boreholes. They allow for formation pressure to flow back into the bore. They are also multi-purpose. The compressed air not only drives the DTH piston, the piston in the hammer, but it also overcomes the in-hole static column pressure. So the air pressure of the compressor overcomes the static water pressure. It also removes the cuttings. It bails out the cuttings. It clears the drill cuttings using the compressor air volume. So you need pressure and volume to achieve your drilling. Further, it is used for developing the well. So this ability for the compressor to be used in multiple ways has made it one of the more popular ways of drilling, especially in Kenya. There's also a separate drilling bit with tungsten carbide buttons connected to the hammer, and this enhances the performance and cost efficiency of the drilling operation. You don't always have to replace the hammer, but you can replace the drilling bit. All these things, like all other mechanical things, require maintenance, and maintenance is key. For example, you need the right compressor. You need the right maintenance schedule so that you can get the best life out of your drilling equipment. Let us switch gears, ladies and gentlemen, and look at some statistics. Now, remember we said back in the day, a 200-meter well took 10 years, and then that reduced to 6 months, and then with cable tool drilling to 3 months. And this is just averages because we are looking at a consolidated formation, we're looking at 200 meters, so these are just averages. But what we see globally is that the penetration rate in meters per hour had an inflection point when hydraulic rigs were introduced into the market. And you can see there from about 1970 on the graph, there's this sharp inflection, and then there's an acceleration in terms of the penetration rates. So it's not a surprise today to get averages of 20 meters per hour drilling. This is very achievable. I think one of the key questions we will be asking ourselves today is faster drilling better drilling? And what are the trade-offs? What do we have to compromise in order to get a long-term productivity from these water wells? I would like to end this presentation with a picture of a pump gantry system, which is in Kwale. This, as you all know, is the famous Tiwi boreholes. And these Tiwi boreholes supply water from the Tiwi aquifer for consumers in Mombasa. Note, this gantry system is no longer installed in majority of the new boreholes. Why? Instead of using the chain blocks and placing them on these gantries, now we have mechanical hoists I think you are all familiar with the land cruisers that have been for a long time been used for mechanical hoisting. This is for the installation and removal of submersible pumps and cables and the associated riser pipes. And now we have the hydraulic hoists. As the wells become deeper, the force or the pullback force that is needed to bring out these pumps is much larger than much bigger, more efficient hydraulic hoists have come into use. So these will be some of the issues that we discuss over the next 1.5 hours. And ladies and gentlemen, I am looking forward to a very thorough, detailed interaction with yourselves. Thank you very much. At this point, I would like to welcome the Doshi team to say hello to the people. And I want to start with Mr. Nilesh Doshi. Please, Bwana Nilesh, you will welcome the people, but allow me first to play the Doshi corporate video.
Okay, fine.
It's just a number. Add years to it. Now that's the game changer. 88 years is a long time to be doing something. It's even longer when you've been doing it right. Hard work pays. Integrity is fundamental, but attitude is everything. Roll up your sleeves. Get your hands dirty. Sweat. Whatever it takes to get the job done. No compromise, no excuses, no shortcuts. Dedication is everything. Dedication to a single dream. A dream to build homes, a better country, a better future. This is our dream. This is Doshi. Our steel built this nation. Our cables connect your cities. We build your homes. And now, a single goal unites us to bring you the most precious resource, water, the very essence of life. It needs to be protected, it needs to be preserved, and it needs to be pure. Using rapid technology, solid global partnerships, we're making sure that every drop of water gets to you uncompromised. Safe, clean water for all. This is what we believe in, and this is what we stand for. Our roots run deep, and so does our commitment. We are Doshi. We are Kenyan. 88 years. We've always been here, and we intend to stay. Built right from the start.
Good morning and welcome. Welcome to all the people for this second session. It's great pleasure for us to invite you. We've got a distinguished panel, all protocols observed. We had very good feedback from the last session that we had. And one of the suggestions was that we need to allow a little bit more time for questions. So I'm pleased that Dr. Gathuru and his team have arranged the webinar in a way where there will be time for people to ask questions, and hopefully you learn a thing or two. So without further ado, I'd like to welcome you all. Enjoy the session. Hopefully you learn a couple of things. And I'd like to thank Kipya and the team for organizing this and giving us the honor of sponsoring the event. Over to you, Dr. Gathuru.
Thank you Bwana Nilesh, much appreciated. I would like now to go to the Doshi team that is supporting the whole effort of what we are doing here today and further on, you drillers. I would like to start with Bwana Raju. I will spotlight you, Bwana Raju, and just wave to the people. Hello, Bwana Raju. Thank you very much. I now go to Bwana Manoj. Bwana Manoj, I spotlight you, also an executive at Doshi. Thank you very much, Bwana Manoj. I know we also have Bwana Randir. Bwana Randir, I spotlight you. Please wave to the people. Thank you very much. And then I go to a very key team there at Doshi who are in the conference room, and I have spotlighted you now. We start with Evelyn. If you could kindly wave, Evelyn, so the people see you. Thank you, Evelyn. We go to Esther. Esther, if you could wave. Thank you, Esther. Then we have Helen. If you could wave, Helen, please. Thank you, Helen. And last but certainly not least, we have Joseph. Joseph, if you could wave to the people. Thank you very much, the Doshi team. I now want to go back on the presentation, and now we would like to invite for the opening remarks the Ministry of Water, Sanitation and Irrigation. And the ministry today is represented by Director Crispin Juma, who is in charge of national water resources. Bwana Juma, I kindly request you to switch on your video and your microphone.
It's done, it's already.
Okay, one moment, sir. I spotlight your video. And Karibu Sana, it's a real pleasure to have you with us today. I invite you to make the opening remarks.
Thank you very much, Gadurumburu. Thank you very much, and good morning, ladies and gentlemen. It's again my pleasure to represent the PS Ministry of Water, Sanitation and Irrigation in this series of forums, this being the second. I think there are 4 series in total. It is our pleasure to participate in this, and we really welcome and encourage this kind of forum. So on behalf of the PS, I'm giving these opening remarks on behalf of the PS who received the invitation and delegated this responsibility to me. So first and foremost, I want to thank Kipya and Doshi for organizing these webinars. This is very, very important because we really need to exchange information, notes. We really need to share in technology so that we can improve this sector. So thank you very much, Doshi, and thank you very much, Kipya, for organizing this series of webinars. Today's series, this technology, is very, very important. We really need to modernize our technology. As you all observed from the presentation by Dr. Gaduru, we come more than 2,000 years back, and we are not at it yet. We still need to improve on technology. Why? Because we need sustainable boreholes. Boreholes are very expensive investment, so we really need to have sustainable boreholes that can serve our purposes and also can give value for money for our clients. So we really need still to keep on improving on technology. But as you also already mentioned, Dr. Gaduru, there's really need for buy-ins. Is quick drilling really appropriate drilling? Does it give us sustainable boreholes? For example, if we do a borehole for a day, is it equivalent to giving us a sustainable borehole, or we're just doing it with speed, but also compromising on the quality of the borehole? So technology should not compromise on the quality of boreholes, rather should give us efficient boreholes, sustainable boreholes that can last years. I recall that there are boreholes which are were done even as early as 60s or 70s, and they were done not with speed, but with patience and getting actual status of that borehole, getting the actual borehole to give its optimal services. And this borehole are in service up to date. But again, then you'll find boreholes done recently, as recent as after the year 2000. Already some are collapsing, some are not giving value of money, the clients are complaining. So technology should not compromise on quality. We need to deploy appropriate technology where required. That is to say, not that down the hole drilling is appropriate in all formations. So we need to deploy appropriate technology where it's required so that clients get value for their money. If you deploy down the hole hammer in very loose formation or sandy formations, then you force the borehole to be a borehole. You're really not giving good service to the client who has entrusted you with this investment. So there's need for buy-ins. And this I want to encourage our companies. You don't necessarily have to accept or take a contract if you don't have the necessary technology. Advise your client that, yes, thank you very much for considering me, but I think my technology is not appropriate for your formation. I think we need to be honest in this industry, so that because we can do so many boreholes and so many are collapsing, then we compromise on our aquifers, such that we have out of 10 boreholes, we have 8 which are not sustainable. And then if somebody else wants to do a borehole in that area, cannot do it because 8 of them were not appropriately done. Further, also, we need to keep records. As we are drilling, we need to keep history of the drilling. We need to keep history as we are drilling. And this is supposed to inform technology. If you're drilling and with this particular kind of technology, but then you're not making progress, it's important that you keep that record and informs the next driller or your next drilling activities on what kind of technology you should deploy. So these records are very important. I know lately people don't keep records of their drilling. This is not good. When you submit for example, the completion record, I think you should also make some remarks. It used to be a practice that we make a remark that in the process of drilling, this was encountered, this and this happened. This should inform future drilling. I think I want to encourage our contractors, our drilling industry, to be able to be keeping appropriate records of their drilling activities. Also, the direction now we are moving is we keep on increasing the depths of boreholes. I don't know how many of our contractors are comfortable at this moment in time to do a 500-meter borehole without struggling. I have information that some contractors take up jobs and, for example, for a 400-meter or 350-meter borehole, but as soon as they hit 300, they are unable to proceed. And the excuse they give is that they tell the client, you already have enough water, there's no need of continuing. They don't inform the client that our technology cannot progress any further. In short, what I'm saying, we need to be honest in this industry. We need to do sustainable boreholes. And I think this forum today is very, very important, very appropriate in that we will sit here, we'll share ideas, we'll exchange ideas. And I think contractors, our drilling industry should be able to be partnering in case you're not able to do a borehole that has been assigned to you for one reason or another, mainly because of technology. I think we need to partner and pass it over to another contractor who has the technology so that we have a sustainable sector and sustainable boreholes. So I want to thank you very much, Kipya and Doshi, for organizing this. We want to hear the modern technology, we want to exchange ideas. And as a ministry, we really welcome this because it is in our interest that we have a sustainable sector, we have sustainable boreholes, we have an industry that is honest to itself. Thank you very much for inviting the ministry, and we are here to participate and listen to you. And if in any way there is need for policy direction so far as technology is concerned, we want to take this aboard and then we can escalate it appropriately so that we have a sector that speaks to itself and is sustainable. Thank you very much, and I welcome all, and I look forward to a very interactive session. Thank you very much. Welcome.
Thank you, sir. We take your comments, which are very clear. There is the issue of sustainability. We need to really look at the work we are doing of boreholes. Is it sustainable? We take on board the borehole completion records, the data. We need to provide the correct data and information. This is the only way we can plan appropriately. We take on board the issue of deeper boreholes. Are we able to go deeper? And in so doing, if we're going faster and deeper, are we creating new problems where we need to ask ourselves, what is the appropriate technology? We take on board also, sir, what you've said on partnership. We truly believe in partnering. We also want to partner with the ministry amongst ourselves because of issues related to policy direction, where we can have one or two things that we bring on board as partners to give some good outcome for the industry. So thank you very much, sir. There's many other comments you mentioned there. I just highlighted a few, but we really appreciate your presence with us today. Now, ladies and gentlemen, we will also have a little bit later in the session, the Water Resources Authority who will be joining us, and they will have one or two things to say in regards to the policy edition, where there were some specific requests made by you, the participants. We will come to that. But for now, I would like to welcome the county governments. Today we have with us Moses Ojulo, who is the Turkana County Government Chief Drilling Superintendent. It is a pleasure to have you with us, sir. Now we go into the core of the discussion, where I want to invite our panelists. We have Tom Armstrong from the Kenya Water Industry Association. We have the chairman of the Geological Society of Kenya, Geologist Gishero. We have with us from Epiroc, Bwana Gerald Wanjohi, who will also be discussing with us. And also from PRD Rigs, we have Bwana Saran Kumar. But for now, I would like to start with Bwana Gisheru. And as we continue with this discussion, I want to urge you all to put your questions in the chat, and also feel free to raise your virtual hand. I will come to you. Today we will allow that you can ask your question directly to the panel. So please feel free to raise your hand, switch on your video, switch on your microphone, and ask the question directly. But now we go to Bwana Gisheru. Chairman, I hope you're there. I ask you to unmute your mic, and if you can, please, your camera is a little bit on the high side. If you could face it slightly down so that we could also see you, much appreciated. Excellent. Thank you very much. So karibu sana, Chairman, and going straight into it, there have been claims about new technology for hydrogeological surveys. And this technology is said to have pinpoint accuracy for water borehole siting. Chairman, tafadhali, please demystify for us the current science and any emerging new technologies for surveying. Karibu sana.
Yeah, good morning, ladies and gentlemen. Yeah, thank you for having myself in this wonderful webinar, and I'm happy to represent the Geological Society of Kenya. And as you know, geological work and activities of our geologists are quite integral in the development of the drilling industry in this country. The question you have raised is of quite significant interest, considering your presentation of the technology development in the last 43,000 years, but more specifically in the last 50 years or so. And may I, in the first instance, point to the fact that the pinpoint accuracy for water borehole siting may not be felt in the casual meaning of the one, considering that siting of a borehole is a process. This process starts with looking at an area, and in this area, we look at how best we can be able to define the underlying aquifers. May I also point at the fact that the science that is available is not a direct science, so to say. It is not like what you say, like measurements of weight or length or time. So principally what we have is indirect science, whereby there has to be data collection, and this normally starts with the available data on existing boreholes. Then if you have to carry out some geophysical field survey, you have to again on site identify the various characteristics on site that would be indicative of the potential of the underground. These include the soil, the vegetation, the topography, and also guided also by the climatic characteristics, including the rainfall and evapotranspiration. And so it is not a straight case of somebody coming with an instrument that says that now we have very accurate siting of this borehole. May I also comment on the various methods which are used for the surveys, and they are quite variant. And these methods are the ones that measure, that define the various physical characteristics or chemical characteristics that define parameters that have to be used in interpreting on whether an area or a site has groundwater. These methods include the resistivity method, which in the past we have normally used the horizontal electric profiling or vertical electrical sounding, but in the very recent past we have had imaging, or what is referred to as tomography, where we can have two-dimensional representation of the resistivity below the ground. We also have methods like seismic. We also have electromagnetic, where we have the very low frequency, and also the horizontal loop electromagnetic method, the audio magnetotelluric, and the time domain electromagnetic method. In these, we are measuring certain electromagnetic characteristics of the ground. We also have magnetic methods, where we also have the measurement of the magnetic field of the earth. We have gravity methods that measure the relative differences in gravity. Now, these are more of indirect methods that measure the physical characteristics, and then the person or the geologist who does that will have to do calibration of the method, get data from existing boreholes to correlate the geophysical measurement. In addition, in drilled wells, we have borehole geophysics, where logging is carried out, and all these data is interpreted by the geologist to be able to determine whether a site has a potential for a borehole development. Now, before the geophysics, there is need, especially when carrying out a large service area, we need to do some remote sensing to be able to identify promising zones. Now, in a nutshell, the pinpoint accuracy that one would be looking for has to be based on analysis of all these data. As the director of the National Water Resources has specified, we need a lot of data to be able to come up with a comprehensive recommendation on whether to drill or whether not to drill. Now, recently we've had several people claiming that they have very accurate methods. And some people have even come to the ministry. I've met some people also outside the country who claim to have methods that can guarantee water in some areas. Now, this has not been proven. And our reaction has always been, if that is the case, why don't you identify an area and then you site a borehole? In case it does not use water, then it is, you prove that the method is not working. However, with consistent data collection and archiving, the one that is stored with the Ministry of, with the Water Resources Authority, it becomes much more easier to analyze the geophysical data because the calibration is much better, and you're able to really be able to point at various parameters that guide on selecting a site for drilling.
Thank you.
Now,
thank you, sir.
Yes.
Allow me, Chairman, to just pick from there. I really like the different types of technologies which you've described. So here it is asking ourselves, is a diviner, a water diviner, really valid? And I know there's a lot of discussions, but what you've talked about is the science. We need to base our water surveys on science. And I really like what you said, consistent data to the Water Resources Authority. So allow me to go to the Water Resources Authority Chairman. We will come back to you, but they have joined us, and I want to invite Madam Agatha, who is the manager in charge of groundwater, to talk to us. She has an update in regards to the policy discussion we had last month. So we just want to take this opportunity to invite her, to welcome her, and allow her to make some comments. Unfortunately, she informs me her video has a challenge, but Madam Agatha, I believe your microphone should be able to work. So if you're there, please proceed, Madam Agatha.
Okay, thank you very much, Dr. Gaduru. I really appreciate this opportunity. Good morning, everyone. Now, with regard to that policy discussion we had in the last session, you realize that our permitting process usually gives the person who wants to drill the borehole the authority to drill the borehole, whereupon then the driller takes up that role and drills the borehole for that client. The end product, apart from the borehole, is that we are supposed to get back the borehole completion records as an output of the drilling process. Between the driller and the supervisor, the borehole completion record is generated, and we usually require that the person you've given the authority to drill the borehole, who is the client to WRA, should return the records so that now we know that they have a borehole, and therefore we now would give them the permit to use the water. I want to just underline that the authorization is supposed to help this person undertake the borehole works, to drill the borehole. After they drill the borehole, before they get to use the water, they need the permit to use that water. So the borehole completion record facilitates this client to be a legal user of the water, not the authority to drill the borehole. Now, in this regard, we are requesting that the drillers who do that very able job of drilling the borehole helps their clients by submitting the records either through them or directly to us, of course, with the knowledge of the user, so that we are able to give the authority, the permit to use the water. I also want to appeal to the drillers that these records are very important because they help us be able to manage the groundwater. One, we get the data on how many boreholes have been drilled around an area. If we do not get the borehole completion record, yes, we can get from being on the field, but the borehole completion record is one that will give much more information than just finding a borehole on the ground. It gives us the GPS point, how the strata of the borehole is. You know, after every 2 meters, we require that you keep a record of what you encountered as you drilled. We finally get to know how you cased the borehole, how you gravel packed it, to what depth did you drill, and also the water quality record, which we require that is taken to a certified lab. And recently we've been requesting that it's taken to the Water Resources Authority lab, even if you're taking to another lab, simply because we need to compare those results and be sure that we are getting the right results. And I want to appeal to the drillers that all those records are important because they help in the management of the water, which we all depend on as the people of this country, the drillers, ourselves, the hydrogeologists, our clients. This information will help us in better planning, be able to protect our aquifers better. So in a sense, I am saying that we are appealing that in your role as drillers, that you get to submit the records to your clients, who are also our clients, or you submit the records to us, and we are able to now give that, keep that information in our database, and also generate the permit for water use for these clients.
Thank you. Thank you very much, Madam Agatha. You have made a very passionate appeal. I know that there has been a lot of discussions over the last 3 weeks within WRA on how to formalize such an appeal. And I know that you have been instrumental to make this appeal directly fast to the drillers. I am asking all the colleagues on this Zoom meeting to please feel free to send in your questions while Madam Agatha is with us, so that we can also clarify any points that you may have. Please also feel free to raise your virtual hand and ask the question. But for now, thank you. The appeal is very well received. And as we progress over the next 1 hour, we will get some more comments and more questions in relation to the same. Asante sana, Madam Agatha. I would also like to mention that we are joined by Robinson Kimari, the Water Resources Authority Sub-Regional Manager for Nairobi, and also by David Mutai, who is the Water Resources Authority Regional Manager for the Tana Basin area. So welcome very much. Also to mention that we are joined by geologist Eliud Wamwangi, the former chairman of the Geological Society of Kenya. Welcome, geologist Wamwangi. And also by my friend, George Kouma of the Small Scale Drillers Association of Kenya. Feel most welcome. But now I'd like to go to Tom. And Tom, I put you now on the spotlight and I have a question for you. Please feel free to unmute your mic, Tom. Thank you.
Thank you.
Tom, I know you have been looking at the technology of hydraulic fracturing.
Yeah.
And please tell us in brief, what is the concept of hydraulic fracturing in relation to enhancing the productivity of water boreholes? And also explain to us, is there a business opportunity for drillers to use this technology in Kenya? Welcome, Tom.
Thank you, Daktari. Hydrofracturing has got a bad name worldwide in relation to what the similar technology for extracting oil sands and shales. There's been a move to change the name from hydrofracturing to high pressure penetration for yield enhancement. What this does is you're looking at the fractures and the fissures within the area underground to open up. And on that point, I'd like to go back to this is a diagram which explains a little bit about what the hydrofracturing is all around. But I would like to reflect on what was saying earlier in this context, whereby faster drilling equals better drilling. This is not the case. What can happen with faster drilling and high pressure drilling is that the cuttings can be pushed into the fractures and the fissures and actually reduce the bore, reduce the yield. We've had experience of this where the worst case was where a driller was engaged to drill 3 boreholes. He did those 3 boreholes virtually overnight. They were in one day down to 180 meters, and he declared it to the client that the 3 boreholes were dry. This wasn't the fact that they were dry, it was just that he had blocked off the aquifer. The end of that story was a good one because we subsequently came with a cable rig and drilled them slowly and got the water back, very high yielding. But related to that, we can look on this diagram, you can see that we've illustrated, what may be fractures and fissures bringing water into the borehole. What the procedure is here is you are coming with packers, and the first 3 diagrams are talking about putting in the single packer. So you introduce the packer, you then introduce high pressure and water into the borehole, and you can go up to 200 bar. And as the pressure is increased, suddenly you'll get what's known as a breakthrough. And that's where you've pushed all of the cuttings that are blocking the fractures or the fissures or whatever. You push them out, and now the water that you're putting in under pressure has now gone into the aquifer. If it can go one way, then it comes the other way, and it comes the other way with a lot more of it. If we can move down with the diagram, Daktari, we're now looking at the lower illustrations. And this is now a double packer system, whereby you've sealed off the borehole above and below a certain fracture that you're looking to hydrofrac. And this can be identified by camera work before you start. So this is just focused on a particular zone, and then you can move over and go to the other zone, and basically you're getting, you know, you just opened up the fractures and the fissures. I'm going to use an example of there's a contractor in the US in the 4 northwestern states, Montana, Washington, Idaho. He's kept very meticulous records of drilling of hydrofracturing, and he's got recorded an average increase in yield of 584% since 1986. That's, I mean, it's really 95% of the holes that are fracked will improve yield. There was a project in the 1990s in Uganda whereby it was a Danish funded project, and 3,000 boreholes were hydrofracked. They had two machines, two hydrofracking machines, and they applied it to 3,000 boreholes over 4 years, and they improved the yield on those 3,000 boreholes. The regrettable thing here is that when the foreign assistance closed, the project closed. So that machinery then went to scrap, and some of it has been purchased by another driller in Kenya, one of our members. But again, it's not being applied. Now, why isn't it being applied? We have certain counties here where it's very, very ideal for hydrofracturing. Turkana, like Kipya, Samburu, Machakos, Narok. There's a great number of our counties can benefit from hydrofracturing. And this is where you have the basement rock underlying the overburden, and often the water is trapped within the top side of those overburdens. Anyway, with the fractured zone, you can get more yield out of these holes. I have to emphasize here that you can't do it within the casing. It has to be within the open hole below the casing, or even before your casing. If you're doing it, you can apply this technology whilst you're drilling, and it can also be applied later, as long as you have an open hole below the casing that's been installed. That's a very important point. The other thing, of course, is that the water that you're applying has to be very high quality. You may need 10,000, 20,000 liters to inject into the ground, and it needs to be proper. You don't want to inject any pollution into the ground. So you don't go and get a local stream and put that in. This can hinder the actual process of hydrofracturing. Talking about how we can bring this into the marketplace, this is not an easy one to crack. I would say let's just. The reason is that this is not proven in this country, and the boreholes that you're hydrofracturing, they're not the high yielding boreholes. You wouldn't hydrofrack a borehole that's over 5 cubic meters per hour, for example, because there's far too much water that you have to put in to actually catch up. It won't work. You're really looking at boreholes which are low yielding, less than a cubic, 2 cubic, say. And and those boreholes, that's where you need to have the double packer system, because you want to seal off other fractures which may be obscuring what you're doing to these fractures that you want to open up. It's quite a skill to do it, but it is worthy to do. If a fracture, the reason that these redundant scrap fracturing equipment from Uganda is not being used is because there's no market. To make people aware of this market is not easy. I've been talking about hydrofracturing in Kenya for about 15 years, and we've yet to get any equipment working here. I think it's really not appropriate for contractors, I would argue. I think, I'm not in favor of counties owning rigs, and we've discussed that before. But a piece of equipment like this, it might be appropriate to put it into at county level. I can imagine the equipment going into Turkana, and there's so many boreholes, and I have a list of boreholes from a contractor there of boreholes that would be suitable for hydrofracturing. But how are you going to get funding for that? It's a problem. So I'm going to leave it there. I can happily tell you more about hydrofracturing if any questions.
Great, and thank you, Tom. Tom, I have a question from Mr. Saran Kumar, who's coming up next on our panel, but I think you may have answered it. He's asking, since most of the boreholes are cased, how would this technology apply? But I think you also made it clear that it would only work below the casing or before casings are installed. Is that right?
Yeah, correct. Yeah.
Okay, okay. But right now I would like to go to Mr. Saran. Buona Saran, if you're there, please feel free to unmute.
Yeah.
Thank you. And you're most welcome to join this session. Now, Buona Saran, we know that the importation of borehole construction equipment, including equipment for hydraulic fracturing, the rigs, the TPUs, the rods, the hammers, the bits, all these come with varied challenges of fluctuating exchange rates, long shipping lead times, import clearing processes, etc. All these add to inefficiencies. Buona Saran, is there a halfway position where manufacturers like yourselves could import a CKD, a completely knocked down kit, for assembly locally and to suit the conditions here in Kenya, in East Africa, in sub-Sahara Africa? Is this an opportunity?
Yes, okay, definitely it is. And as we speak now, already we are importing some of these small drilling rigs and also the pump insulation. And so this gives greater flexibility of variety of trucks. Also, sometimes the customer has a truck and he wants so basically this helps to reduce the cost of a certain group of equipments, but not the drilling rigs.
Okay.
Because significantly there is no difference in taxation for the CKD unit versus the fully built units. Actually, the fully built units are duty free as well as the CKD. At the end of the day, the price difference, price benefit, what we are going to pass to the. But on the other hand, the hammers, this contribute almost to 5 to 7% of the expense. But, okay, unfortunately, still we are not able to do a manufacturing setup here in Kenya just because of the volumes. Because these manufacturing setups, you need a huge investment, like machinery-wise and technology-wise. So the market size is not yet up to that. Maybe if we cover the whole of East, Central, and including Ethiopia, then maybe in the future, maybe next after 5 or 7.
Okay, so thank you, Buona Saran. On my side, I was having some breaks in your speech, but we have got the gist of what you've said. One, there is the issue of taxation, no major difference because of the zero rated duty for a complete rig, CKD.
Yes.
But also you went on to talk about tools and the manufacturing of tools Now, the key thing which you ended with there is the issue of the high investment and the size of the market. So I think we got you there, right?
Yeah, you got it right.
Okay, and that with time, the market is growing. And if we look at Central Africa, the bigger Sub-Sahara Africa, continental Africa, there could be some opportunities, correct? Wonderful, wonderful. Thank you for that. Bonasaran, we'll come back to you. I would like to show a slide, and this slide shows the result of a survey that we did. And this survey was directed to drillers. And we asked a technology-related question. What is your main concern in relation to borehole construction and technology? What came out is there's a lot of imports, and this is some of the things that Bonasaran was addressing. The issue of pricing, and he's been clear for us that when it comes to assembly of these kits, the price difference is not there to a great extent because the rigs complete are duty-free. But then there's the question of the tools, and can the tools, the rods, the hammers, the steel bits, can those be manufactured locally? So again, we need to look at what's the market size, what is the investment, and can we do this for a greater geographical area so that we get the right economies of scale. Now, I would like to move on to the next item that was highlighted on this survey, and that is drilling and pumping energy efficiency. We know that the rigs consume a lot of fuel. And I would like to bring in Gerald Wanjohi. Gerald, I'll request you to start your video. I will also spotlight you here. And I have a question for you, Gerald. Karibu sana. Gerald Wanjohi is the business manager for Waterwell in East Africa for Epiroc. Gerald, one of the major operational costs of borehole construction is the energy cost. That is the fuel consumed for the pneumatic or air drilling, in addition to the fuel required for running the hydraulics. Please tell us, what are some of the modern features on a drilling rig that investors should consider in relation to energy efficiency? And are those features relevant for our market? Further, what would be the prerequisites in this country to start powering borehole drilling equipment with other energy technologies apart from diesel? Karibu sana Bwana Wanjohi. Gerald, I'm sorry, Bwana Wanjohi, we don't hear you. Yes, now we hear some noise. Try that.
Can you hear me now?
Yes, thank you.
Yeah, so I was highlighting most of the drilling sites you'll visit. You'll find that there is a compressor, a truck carrying a compressor. Then you'll have another truck carrying the drill rig. You'll have another truck carrying accessories. Then you'll see how many engines you have to mobilize to get to site. Or alternatively, you could have a truck which is carrying a rig and it also has a compressor on board. That you will find that in all these cases, when you are actually drilling, you will have to learn The compressor runs the engine that runs the hydraulics. So you end up consuming a lot of fuel, and sometimes the compressor engines are very big. You might find that the well you are doing is not even that big, that does not require so much output in terms of pressure and volume as what you have available. So in such cases, you will have to be running a compressor which is using a lot of fuel. So what we have done, or what has happened over the years, is that technology has been developed whereby you have now one engine. You can have one engine on the rig, and this engine is running both the compressor and the hydraulics. A lot of cases, and there are quite a lot of units in the field where you have a compressor on board, the same truck on the rig, but then you still have to run the compressor and run the truck engine because you are possibly running the hydraulics through PTO. So you still have to run two engines at a time. So when you have one engine on board and the engine runs both the compressor and the hydraulics, then you have a lot of savings. What is happening is that the engine is built in a way that on one side there is a compressor element, so you get a compressor driven on one side, and on the other side you have the hydraulics. And that saves a lot. Then we also have an electronic regulation system which has been developed over the years, whereby the operator just gets the amount of air he or she requires. So what happens is when you are running the rig, the operator is able, through electronic regulation, to just indicate how much pressure, how much volume they need. Depending on the well you're drilling, you can be able to do a number of things. You can be able to control the down the hole hammer. If you're using a down the hole hammer, you can be able to control the walling by having only what you need. You only need a certain pressure for a certain period. You only need a certain volume for a certain period. So the EARS system, that is the electronic air regulation, is becoming a tool that must be there in drilling. The system has quite a number of advantages, like I've said. You can see it gives variable airflow that controls the hole and development of the well. Of course, it has the control of the down the hole hammer, and then you have a lot of fuel efficiency. You have reduced fuel efficiency. When it comes to alternative sources of energy, which you can use for drilling wells, we have the direct electric motors, used especially when you are drilling very big commercial wells, big diameter commercial wells. Usually in countries like Ethiopia, you find that they have to do very large diameter wells and very deep wells going to 600, 700 meters. A lot of equipment are used directly, powered directly through electric motors. This, we don't have a lot of, we don't have specific guidelines on these ones, because basically is what you are able to mobilize. You'll find that some companies have also developed battery powered system, like you have like Epiroc has developed battery powered rigs to drill, especially for underground operations. And this is slowly coming to service rigs, which include water well rigs. I think, Daktari, I have answered, I don't know if I have answered the question the way you asked.
Absolutely, you have. Thank you, Bwana Wanjohi. We got you loud and clear. Electronic air regulation, that is an immediate way. And as we all know, electronics are getting more robust. So indeed, it's good for environment. And thank you for those alternatives. I think the drillers, the investors on this forum will be looking for those electric motors, those batteries, because as we all know, the fuel consumption, the diesel consumption is very high. So the alternatives are very welcome. Thank you so much, Bwana Wanjohi. I'll be coming back to you. I have some comments from Patrick Murunga. Patrick, if you want to vocalize your comment, feel free to unmute Patrick, because there's something that you wanted to talk about in relation to hydraulic fracturing, but I allow you, Patrick, at the Kenya Water Institute to vocalize your comment. Okay, he's put it in the chat. I'll say it for you here. Hydraulic fracturing is very welcome technology, but obviously involves very expensive equipment, which will be shunned by ordinary contractors and clients. Government, through Water Resources Authority, will be able to introduce such technology, especially for developing dedicated aquifer monitoring wells. Thank you for those thoughts. Samuel Kamau, you have some comments. Samuel, feel free to unmute and vocalize your comment. If I can immediately get to you, Samuel, we can try to address some of your concerns. Okay, Samuel, you can vocalize your concern.
Yes, thank you very much for this webinar. My concern to this technology where we have to introduce some hydraulic pressure into the aquifer, or rather where we feel there is some kind of obstacles. I feel that the science is very well and the simulation can be very okay, but when it comes to practicality of that technology, I don't know how the technology can maintain the efficient and sustainable recharge into the aquifer, and also maintaining the issues to do with the different geological formations and the normal way of recharge into the aquifer. How does that technology maintain that state?
Okay, thank you.
Yes.
Great, thank you, Samuel. I want to go to geologist Geshero, Chairman. Maybe you can give your views on hydraulic fracturing, try to address concerns from Samuel, and also talk to us about this issue of is faster better? I think Tom alluded to some of his concerns about going too fast, like blocking off the aquifers, but we are happy to hear your opinion. Please unmute your microphone, sir, and proceed.
Yeah, thank you again, Dr. Gafuru. I think on the question by Samuel about the hydrofracturing, like it was explained by Tom earlier on, in Kenya it has not been used a lot, but in Uganda it was used in the early 90s when the government was still the one that was doing most of the drilling work. But with the privatization of the drilling programs in Uganda, the method failed. But mainly it was used in basement areas where to increase the transmissivity of areas that were not found to be water bearing, but where there is some significant fracturing. This method was used to increase the yields for boreholes that were very low yielding. Now, of course, it requires very accurate data so that you know at what depth that you expect the fracturing and where to target with these secondary porosity creation, in order that when you use the detonations, you don't, it is not in vain. Sometimes when the case, if you don't locate the casings properly and if you're not sure about the installations, it is also very risky, because when you blow up, you may blow up from the bottom of the casing and you lift the entire casing pipe up above the ground, and it can also be very risky. So this is a method that has to be also applied with a lot of care and public education. Now, before I look at the issues on the trade-offs, I wanted to summarize very quickly the different methods or the technology for hydrogeological survey by stating that out of the different methods, there's not a single method that can be applied in all circumstances, because as explained that we are measuring physical parameters, it is important that the surveyor or the hydrogeologist doing the survey will have to choose the method depending on the characteristics of the aquifers that he expected. For instance, to undertake a reflective survey, you must comfort yourself with the fact that the area you are working on, there is a differential between the various zones from those, different zones. The zones bearing the water must have a differential in resistivity from the non-water bearing. Similarly, in seismics, you have to see the wave velocities in the zones that are bearing water. They must have a different wave velocity, and so on. Even and this is why you find in some areas, one method will be better than the geologist by the machine. Now, I think that is my summary on the methods, but you had also raised the other question about the quality and trade-offs during drilling and how these can be mitigated. Now, there are various aspects of the drilling process that really, as you explained, the improvement of the speed of the drilling has brought about some challenges, particularly so on the data that is used for the design. Sometimes when you have 20 meters per hour drilling, if you don't have a keen drilling supervisor, you may bypass the data for some of the aquifers. Again, you may not get proper data on the water quality in some areas whereby you have saline aquifers. This data may not be collected accurately to ensure that it guides in the design of the boreholes. There are also other attributes that the water struck levels, the estimate of the yields, and these are pertinent in making a proper design. Now, in the process also, one of the key activities in the borehole construction and development is actually the cleaning or development of the borehole, which many times is the one that guarantees the productive life of a well. And in order to sustain the water supply, this particular activity needs to be done correctly. The other aspect in the carrying out of the works is the water quality monitoring, where we have issues relating to salinity or pH. And also another one is the test pumping, accuracy of the data collected. This is the one that guides in the design of the productive, production pump that will be used during operation period. Now, the other thing that needs to be done in case where you have challenges in these identification, you end up having a challenge design where probably the main aquifer zones are not matching with the screening of the borehole. Now, in mitigating this, sometimes you carry out geophysical logging of the boreholes to be able to capture the productive zones. And generally, we recommend as professionals proper supervision by a qualified person for all drilling. Now, this is one of the aspects that has not been taken very seriously, and we request that the people start looking at the different actors to do their work. In this particular case, for geologists during supervision to ensure there is proper logging, proper data collection that can also be filed with the WRA, and final documentation of the borehole record. Thank you. Thank you.
Thank you, Chairman. Very clear. And thank you for that summary about the technology. Much appreciated. And also what you've said there, professional supervision. I think this is something that will be coming out from this session in a very clear way. Asante Sana, we'll be coming back to you. I'd now like to go back to Tom. Tom, feel free to unmute. And Tom, we have a question here on borehole construction material, specifically borehole casing. And the question is, what is the appropriate dimension of a borehole steel casing pipe, especially in terms of the thickness of this pipe? What is appropriate, and why is it important in relation to what Chairman was saying, lifetime productivity of the well? What is the relationship? Tom, please.
Thanks, Daktari. Let's first of all consider the general conditions in Kenya. There are some countries where boreholes can even be 4-inch diameter because they're being drilled for hand pumps. There are submersible pumps available in Kenya which can go inside a 4-inch casing, the SQ pumps. You can also get the conventional 4-inch pumps which will go nicely into a 5-inch casing. But generally we're drilling 6-inch boreholes. That's the normal borehole. And we're drilling it at 203 millimeters, which is 8-inch. I personally don't think that 8-inch is appropriate. We like to drill at 8 and 5/8, which is 219. The reason for that being is that the outside diameter of the 6-inch casing is 163, and that only leaves a 20 millimeter annulus around the borehole to get the gravel pack in and so forth. There's not enough space. So a larger borehole is actually more appropriate. Now, why 6-inch? 6-inch is there even for the 4-inch pumps. When you're drilling a borehole, you don't know what yield you're going to get. I mean, the maximum yield for a 6-inch borehole is generally around about 25 cubic, depending on where the static water level is. And usually a lot of customers, they only need about 5 or 7 or 8 cubic meters per hour. And that can readily be done by a 4-inch pump. But again, we're putting it into a 6-inch borehole. Personally, you know, the cost of 5-inch casing is, there isn't a lot of saving with the present pricing structure, because 5-inch pipe is rare. But let's just look at this, just the 6-inch casing itself. And there's 3 parameters of strength that you want to be looking at, which is the tensile strength, the compressive strength, and the collapse strength of the casings. Now, all of these parameters must be adequate. If you've got a shallow borehole, you know, up to 100 meters, I mean, people are using UPVC casing, but it's not as cheap as it used to be. Now, it's a very similar cost, and I would always be inclined to talk to the customer about putting steel casing in, because if you ever drop a pump into a plastic cased hole, you often have to replace the whole of the asset, because the PVC can break up during the fishing exercise. Not necessarily, you can be lucky to get it out. But the point is that the 4.5 millimeter wall thickness of Class B is basically adequate for all purposes. You don't have to really look at it very hard about the compressive strength, if you like. Whatever you need to do in terms of pushing the casing in, perhaps, you're going to have enough strength with Class B casing. Class B is a normal international standard, a normal practice for a 6-inch borehole, because it's known to meet all of the parameters of the tensile, compressive, and collapse strengths that may occur. To the point there now that the Water Resource Authority's Code of Practice for Drilling Boreholes clearly states, and I quote, "For steel casing, the minimum Class B mild steel black pipes shall be used." So this has been laid down by government. However, we do find that many drillers are using undersized wall thickness. It's very common very common practice in Kenya. In fact, I would say the majority of drillers are using undersized wall thickness. And you know, and you can ask ask Doshi. I think Doshi will tell you the range of casing wall thicknesses that they sell. They do sell 4.5 millimeter. There are drillers that will strictly use 4.5 millimeter, but there is a demand also for 4 millimeter and even smaller, even 3.5, 3.6. Now, the client doesn't know this. The clients don't check on the wall thickness. They have their faith and their confidence in the driller. There is very little supervision of the drilling exercise, and it's only when you've got a number of boreholes perhaps that you may have such supervision and people that will actually check on the wall thickness. This is a money saver. Obviously, the thinner wall pipe is cheaper, but it skews the pricing, and it skews the competition. It means that when you're putting in a quotation, you can quote cheaper for the casing. We actually, my own company makes a sales point of this because we stress to customers what the government regulation is, and also how that we believe that 4.5 millimeter is the correct wall thickness. But generally speaking, I would say that in Kenya there are few boreholes. The minority of boreholes are drilled to spec. So this means that when the casing has been installed, if the compressor, if they're having to push on it, you may have deformity in the casing. This happens likely. The welding of the thinner wall casing again may disturb then your tensile strength. There's a lot of compromises that can happen with the smaller wall casing. I'll leave it at that. Thanks, Dr.
Okay, thank you, Tom. Very clear. And thank you for explaining tensile strength, compressive strength, collapse strength. These are important. I think we see issues when driving casing, when fishing pumps, and we much appreciate that you've given us these overview. I'd like now to go to Bwana Saran. Bwana Saran at PRD. And Bwana Saran, we are now going into the final remarks. So I try here to bring you in, Bwana Saran.
Yes.
Feel free to switch on your video and your microphone.
I guess it is on.
And Bwana Saran, I'm just going to try to identify you here. Is your video on?
Yes, it is.
Okay, yes, I have you there. And Bwana Saran, I'll just put you on the spotlight, and I just want you to tell, in relation to what we've discussed in terms of technology, what is it that PRD can assist with? Where can we find you? And any other closing statement that you may have. Please, sir.
Thank you for the opportunity. So, okay, in terms of technology, or in terms of getting better equipment, we have a lot of customers complaining that also the Share mentioned, they don't reach the recommended depth because they say the water is enough, but in reality they are not able to drill through the water what they go to the recommended depth. So in this means, they compromise the shallow depth, which may in the long run will result in a very bad situation where you may not get water at the shallow depth. So equipment wise, we have now the larger sizes of rigs, where you'll be able to reach the recommended depths, even if there's a lot of water in the table. So that, where you don't extract the top water is very low. So that is one thing we are customers. Their products are.
Okay. Okay, Bonasaran, again, we had some challenges with your microphone, but I got the gist of it. I just re-emphasize, you say you are happy to assist to reach the appropriate depths. There's a challenge of going deeper, a challenge of reaching the agreed depth with the geologists, and that you all at PRD would be happy to assist for anyone having those challenges. Is that right?
Yes, you are right. You got it.
Okay, thank you. Thank you very much. Much appreciated. I would like to bring in Gerald Wanjohi. Wanjohi, feel free to turn on your video and also unmute your mic. And Gerald, just to bring you here, if you could give your closing statement. What is it that Epiroc can do by way of technology in regards to what we have spoken about today, and where can we find you, please?
I will start by introducing Epiroc. Epiroc is basically hived out of Atlas Copco. It is the drilling wing for Atlas Copco. What happened is there was a split in Sweden where Atlas Copco was split as the compressor establishment, and for the mining, that is the drilling things for mining, water well, oil and gas, they were all put under Epiroc. So physically in Nairobi, we are also not sitting in the same place where we used to sit. We are sitting at Samia Business Park. That's where the offices of Epiroc are, so you can find us there. For those who may have been trying to go for drilling tools or drilling machines from Atlas Copco, you may have been referred to us. We are sitting at Samia Business Park, just above Porsche, next to KRA offices. I would like to mention that for Epiroc, we have come up with a rig that is doing up to 300 meters with a common engine. That is a common engine on board, whereby you have an engine running both the compressor and the hydraulics. So you have a lot of savings for a rig in the range of 300 meters. For the deep holes and big diameter wells, we have, through our competence center in India, we now have a rig that will drill up to, will have a pullback of about 80,000 pounds, which is about 35, 36 tons. That will improve the drilling depth that you can do. You can, well, we may not need to drill these very deep holes, but you can easily achieve 400, 500, 600 meters. You are welcome. You can always come for drilling tools. We have now a lot of products also coming from India. Initially, we only used to produce these products in USA and Sweden, and then the prices could have been prohibitive to some of you, but then we have a lot of products now coming from India and China. So you can visit us at our offices, and we'll be glad to receive you and give you more information. Thank you.
Thank you very much, Gerald. Much appreciated for joining us. I would like to now go to the Geological Society of Kenya and to request Bwana Gisheru to give us a brief closing remark. Karibu.
Yeah, thank you again. And in my final remarks, I would like us to revisit the earlier discussion where we agreed that we need to give the full benefits to the investor of the borehole. And in this case, we need to observe professionalism at the different levels of the borehole drilling process, like from the hydrogeological survey up to documentation. Now, that way we will be able to reduce the costs to the client, increase the productive wildlife and ensure that we are complying with the code of practice. My proposal is to ensure, because of the many problems arising due to brokers and dubious actors, it is important that the final data submitted to WRA should be properly executed and signed for by the geologist who did the survey and supervision, as well as the contractor who carried out the actual drilling, development, test pumping, and installation of the pump. Because that way you can be able to guarantee that there is no ghosts involved in this whole process. Thank you.
Thank you very much, sir. Much appreciated. I go to Tom, and Tom, I request you to make your closing statement. Feel free to unmute and proceed. Thank you.
Thank you, Dr. Concerning the hydrofracturing, my recommendation is that for certain counties, it should be mandatory that all boreholes drilled should be hydrofracked. It's very possible to put a suitable pump and compressor on the drilling rig itself, and let it be done like that. I would also encourage all of the counties to make some more investigation into this subject. I'm available to be able to advise directly to the county about this subject. It's a pet subject of mine. Concerning the casing, it disturbs me a lot that we don't have standardized use of the Class B casing, although it is mandatory from the government. It's part of the code of practice, and I would encourage all drillers to use it. You can, it's in the pricing, and you can actually use it as a sales point that you are using strictly the right casing for the job. Thank you, Dr.
Thank you very much, Tom, and much appreciate your contribution. Thank you very much. And now I'd like to go to Water Resources Authority, geologist Agatha, for her closing statement. Madam, please feel free to unmute your microphone and proceed.
Okay, thank you, Dr. Kaduru, for that very good discussion. I must say I've also learned a lot. Mine is just to, first of all, appreciate what the drillers are doing, and yourself as well, because we are able to meet water needs for the people of this country. My appeal is that we observe professionalism. Isharo has mentioned the issue of having a hydrogeologist being on board with the drillers, purely for ensuring that the records are being kept, as I have explained before, that the records should be correct, to be that whatever we put in there is as nearly good as it should be put in, and also the fact that since we are all one system leads to the other, that we all try to do our part and do it well. I know our clients also trust drillers to do the work for them. One, that we observe the professionalism with regard to ensuring that the records are returned to us. And also, like Armstrong is saying, let's ensure that we are giving our clients the best products that they need to install in their casing. It's a lot of money, and if we can get to have infrastructure that will last, that will be good for all of us. there's also the part that I don't even know how to start it, but I would want to appeal to all of us to see how we can have trained drillers. I've seen in other countries that drillers get to be certified to work on a rig, and I think that is the way we should go. However, that is, I think, a discussion for another day. It's just something to think about, because also the knowledge with the driller is very important as he works together with the hydrogeologist. Thank you so much for this forum. Thank you.
Okay, thank you, Madam. We much appreciate you joining us today. And also, please pass our warm regards to CEO Mohamed Shourie. We are grateful that he asked you to come, and we look forward to interacting with you further as we move this conversation ahead. To close, thank you. To close, I would like now to go to Director Juma, and I'll request Director Juma to unmute his mic and kindly proceed. Karibu.
Thank you very much, Dr. Gadoro. Thank you very much, gentlemen, ladies and gentlemen. Very, very rich discussion. You will realize there's a lot of information, a lot of very, very important information outside there with very experienced people like Armstrong and others. One would wonder whether all this experience, all these years of gathering information and data and experience is being documented for present and future generation. Agatha has mentioned drillers training. I know this course was discontinued. It used to be at Kewi, but we need to revive it. And I think with the experience gathered, because there's classroom training, but there's also on-site training. And I think people like Armstrong are very, very rich in this. And if we could be able to document this and also invite the likes of Armstrong to give some lectures to drilling students, I think this will be very, very valuable. I would really want to encourage that for food for thought, maybe Kipya and Doshi, if you could be also preparing maybe some quarterly or annual reports where we put all this information in a booklet or a magazine, and then it's available for the drilling sector, so that ideas are, because I don't think all of us were able to participate in this webinar, and because of the limited time, maybe some of us were not able to make a contribution. So if this information could be documented, maybe in a magazine, a booklet, and then it's available to the drilling industry, I think this can go a long way to sustain the sector. Finally, I also want to, on issues of standards, I wanted to mention that there's some thoughts going around in the ministry to develop something that something akin to a manual, borehole drilling manual. It's a generic manual where standards are set that for this type of borehole should be developed in this manner. Something like a design manual, generic, but not precisely to be. It's like it's akin to a manual where we have a civil engineering manual, design manual. So there are these thoughts being put in place, and we'll be sharing with the sector, with the industry, to give their input. It's a generic, is not firmed up that a borehole must be done this way, but we're giving some guidance on how a borehole should be done and what types of material should be put in a borehole, and in general the whole history of a borehole, how it should be done. These are thoughts that are being developed at the ministry as a way of developing policy, and of course, because it has to be participatory, we'll be sharing with the sector players for their input, so that we have something like a manual, a drilling manual that will guide on the drilling sector. These are thoughts that are coming, and I will be giving you more details as we proceed. Otherwise, I want to thank once again Kipya and Doshi for putting together this webinar. And we hope it won't end after the 4th series, and it's something that we can be doing regularly. I know at this moment in time with COVID pandemic, we cannot hold what East Africa Waters used to do, the conference or workshop. But I think the webinar has given us a way forward, and now we can be interacting as a sector. This is very encouraging, and I think we should continue even after the 4th series. Maybe we do another round of same series again. This is food for thought. Maybe Doshi and Kipya can think of it so that we don't stop after the 4th series. Having said all that, thank you very much. I'm looking forward to future webinar, and as a ministry, you're always available to participate in this and take aboard what is being presented, and whatever the sector wants the ministry to do with respect to creating an enabling environment, you're available for that. So we look forward to maybe after the 4th series, maybe some presentation, some memorandum being presented to the ministry on what the sector is the thoughts of the sector and how the ministry can support the sector. Thank you very much, ladies and gentlemen. Thank you very much for inviting the ministry to participate in this webinar. Thank you very much, and bye-bye.
Thank you, Director Juma. We have taken on board your comments very positively, and we certainly will be discussing as an industry and as partners on a quarterly annual report, a memorandum on the sector issues, where support is required from the industry on the borehole drilling design manual idea. Sir, I would like to assure you we are available and we are ready to assist to put this together for the benefit of Kenya. I would like to thank you very much for your attendance. I would like to thank you for your participation and engagement. Also, please pass our warm regards to the Principal Secretary and also the Cabinet Secretary, and let them know that the drilling sector in Kenya is looking to the future, and we want to contribute in a positive way. Asante sana. I now would like to inform all of you that we would be very pleased to receive your feedback on this session, and in the same feedback form, you will be able to claim your discount from Doshi Steel when you next visit with them. So see there a link in the chat with the feedback and claim your discount as well from Doshi Steel. We will also be sending that link via email to all of you. Also to let you know that the next edition of the Water for I, as encouraged by Director Juma, will be coming, and we will focus on the future of the water borehole industry in Kenya, but specifically in relation to financing solutions. So we will be talking about money. The date will be communicated to all of you. I would now like to request all of you, please switch on your videos. Please switch on your videos so we can say thank you to you, and also to all the panelists for joining us today. We would be very, very pleased to see all of you. And also, as we are waving, wave and say, Asante sana, thank you so much. We appreciate you a lot. Thank you for your time, and we look forward to you joining next time. Thank you.
"88. It's just a number. Add years to it. Now that's the game changer. 88 years is a long time to be doing something. It's even longer when you've been doing it right. Hard work pays. Integrity is fundamental, but attitude is everything. Roll up your sleeves, get your hands dirty, sweat, whatever it takes to get the job done. No compromise, no excuses, no shortcuts. Dedication is everything. Dedication to a single dream. A dream to build better homes, a better country, a better future. This is our dream. This is Doshi. Our steel built this nation. Our cables connect your cities. We build your homes. And now, a single goal unites us to bring you the most precious resource, water, the very essence of life. It needs to be protected, it needs to be preserved, and it needs to be pure. Using rapid technology, solid global partnerships, we're making sure that every drop of water gets to you uncompromised. Safe, clean water for all. This is what we believe in, and this is what we stand for. Our roots run deep, and so does our commitment. We are Doshi. We are Kenyan. 88 years. We've always been here, and we intend to stay. Built right from the start.